Well, I think I'm going to be standing most of the time, but...
Duncan, I'm using this tool. I will not look into it. Ladies and gentlemen, welcome to this next session. I'm Andreas Flache from the University of Groningen. I'm sharing this session. Well, so please find your seats. We have to look forward to a great session. Our first speaker doesn't need any introduction actually, but still I will briefly introduce Duncan Watts. It's really a pleasure to have him here. So Duncan Watts is principal researcher at Microsoft Research. There are many important contributions he has made to computational sociology on the theoretical level with empirical work, also meta-theoretical if you want. And Duncan is probably one of the few people on this planet who is a physicist by training and was a professor of sociology at Columbia University. And this link between social sciences and physics is, of course, what was really very prominent in his work. So we are very much looking forward to your presentation, Duncan, which will be about an experimental study of collective self-organization in crisis mapping. So.
Thanks, Andreas. We have the other physicist who is also a professor of sociology in the room as well, Dirk. So there's two of us on the planet. They're both here.
Very few.
So it's great to be here and really fun to follow up on this morning's session, which I think covered a lot of interesting themes. And I want to pick up on a topic that Michael Macy mentioned, but then helpfully did not elaborate on, so he gave me the opportunity to do that, talking about, he mentioned virtual labs, and I want to spend this morning talking about virtual labs, and I want to do it in the context of a sort of a big, interesting, substantive problem in social science, namely how do people solve problems collectively. And I want to start off by talking about organizations, and organizations is sort of an interesting topic to discuss with people, because I think the analogy that I make is sort of organizations are to people like water is to fish. It's something, these are things that we're all part of, that we sort of know about, and yet they're so pervasive and we're so used to them that we don't sort of really think about them as interesting problems to be studied. And yet when we look around, organizations are indeed everywhere, and most of economic and a lot of social life revolves around organizations. So if we think about the economy, which is a multi-trillion-dollar system, it's almost entirely organized around firms, which are just collections of people who are organized to accomplish some sort of collective goal. And in addition to firms, we also, the other sort of big part of the economy is really the government, and you could sort of throw in the non-governmental sector as well. We have other kinds of organizations like bureaucracies and non-profits that solve other kinds of problems in society. And we often argue, at least in the US, we argue a lot about whether government organizations are really good for anything, and if so, what, and how should they be organized, and should they be bigger or smaller. And so these are certainly topics that engage and sometimes infuriate people, and yet they're rarely sort of the subject of scientific discourse. And finally, when we think about organizations, there are a sort of increasing number of problems that are not solved by any particular or single organization, but rather are solved by consortia or collaborations between organizations. And so when we think about crisis response, that's clearly an example where something really bad happens, and not just one organization, but many organizations will descend on the scene and then sort of run around like headless chickens, trying to figure out what to do and who to collaborate with and how to get what is needed to where it needs to be. And sometimes this seems to work very well, often sort of remarkably or even miraculously well. If we go back to 2004, when a tsunami hit the coast of Banda Aceh in Indonesia, it's an incredibly remote part of the world, and nevertheless, hundreds of organizations managed to get themselves there, through this tiny little single unpaved road that goes along the coastline there, and transformed an absolutely devastated area into something that resembled an orderly recovery scene. And then sort of in the heart of the richest country in the world, a few months later, we have a Hurricane Katrina, and a sort of object lesson in how not to do inter-organizational crisis response. And so sometimes these things work very well, sometimes they work very poorly. We don't really understand why, and that would be, I think, a tremendously important problem for computational social science to set for itself. Now, in the midst of all this discussion of organizations, we have another sort of very interesting phenomenon that is also scientifically interesting, which is the increase in what we might call crowd work that we've witnessed in the last decade or so. And so if we look at signature projects like Wikipedia, we look at crowdsourcing websites like Amazon Mechanical Turk. If we look at citizen science projects like Galaxy Zoo or Foldit, if we look at sort of recent interesting experiments in prediction markets like the Good Judgment Project, we see an increasing number of examples of problems that once upon a time would have been allocated to, would have been solved by a firm or by a government organization, and are instead being broken up into micro-tasks, into very small chunks of work that are then parceled out to individual workers, and then the results are sort of re-aggregated automatically by the initial requester. And so we see lots of interesting examples when we look around, and sometimes these examples are motivated by people just volunteering out of interest or public spiritedness. Sometimes they're being paid money, usually in the form of piece rates, where they're just given a small amount of money for a very specific task. Other times, as Yuri mentioned, they're motivated by prizes. We see them all over the place in science, in knowledge production, in creative projects. So it's clearly on people's minds, how far can we push this model? And if we think about organizations as being the traditional dominant form of economic and social production, and now we have this new model of crowds, can we take this model and push it to accomplish maybe everything that is currently accomplished by organizations? Can we build helicopters with crowds? It's not clear. And so when we think about this question of whether we should do things with groups, and by group here I mean an organization, a group of people that is sort of formally organized and constituted and interacting with each other in some semi-intensive way, versus a collective, which is sort of this loose aggregation of people who are really interacting just through the individual who's allocating the work, which is good for what? And as with all questions in social science, the answer is it depends. And in particular, it depends on which sort of branch of theory you happen to read. And so if you read two roughly equivalent books in terms of their historical importance. The Wealth of Nations by Adam Smith and Connected by Nicholas Christakis here in the front row. We can convince ourselves that people who are organized into groups do better than disaggregated individuals. And there are some very good reasons for this, as Adam Smith points out in the very first sentence of The Wealth of Nations. The division of labor is an incredibly powerful engine of economic productivity by splitting up a complicated task into subtasks and allowing individuals to specialize in particular elements of that task. You can dramatically increase the productivity both of the individuals and of the groups. And as Nicholas and James Fowler pointed out in their book many years later, there's another reason why you might think groups do better, and that is that they learn from each other, that individuals don't have to solve every problem on a blank slate. They can observe that other people have solved the problem, and so they can piggyback on top of the learning of others. And so that's another tremendously useful outcome of solving problems in groups. But of course, there's a flip side to these observations, and there's other equally well-known books in the social sciences that talk about, well, when you put people together, they don't work as hard, right? And this is another sort of empirically documented phenomenon, whether you call it free riding if you're an economist or social loafing if you're a psychologist. It's well known that individuals tend to, when they're the only ones who can do the job, they work harder than when they have other people to rely on. People have often observed that groups of individuals don't just learn from each other, they actually herd, they follow each other, they're subject to groupthink. We also frequently observe coordination failures when we put groups of people together. So depending on which theory you focus on, you can convince yourself that either outcome, either organizational form, the group or the collective, is superior. And so, as is often the case, when you want to tease apart different conflicting theories, you have to do an experiment. So what kind of experiment are we going to do here? Well, as Michael mentioned, the web and the internet more broadly is allowing us to do the kinds of experiments that we used to do in the university psychology labs online, and we've started calling these experiments virtual lab experiments. There's no necessary association with Amazon Mechanical Turk, but this is just sort of how things happened. Amazon started this site called Mechanical Turk back in 2005, which has subsequently become a popular destination for, or a popular labor market for crowdsourcing. In about 2008, when we discovered it, we quickly realized that we could use this crowdsourcing site as the sort of 21st century equivalent of the psych lab. So rather than bringing undergraduates into a room in a university building, you could recruit people from essentially anywhere in the world. It's not actually anywhere in the world. It's mostly in the US or in India. But you could recruit many hundreds of individuals from relatively diverse walks of life and have them interact with each other in a virtual environment. And so we've been doing that for several years now. And there's a number of experiments that I won't have time to discuss today. But one of the problems that we have sort of bumped up against in designing and conducting experiments online is really the same problem that many people have observed about experiments that were conducted in physical labs over the years. And so this critique goes back to the 1960s, that the kinds of tasks that we can get people to do in a lab environment tend to be highly stylized. So they're necessarily simplified in order that we can have a level of experimental control, and that people who are just sort of recruited and off the street can actually do the task, and they don't require sort of high level of specialization and training ex ante. The kinds of interactions that they're allowed to have, the networks that they can form, tend to be highly artificial if they have any networks at all. and the kinds of interactions that they have with each other are also very limited. So, maybe I can see this, if we're playing some game of, prisoner's dilemma on a network in a lab environment, I can see the action that you took in the previous round, and I can see the score that you got. So that's a type of interaction, but it's not the kind of interaction that you have in a real organization, the kind of interaction that you have with your coworkers at a firm or with your friends in a social organization. And so the result is that it's actually really difficult to take the output of experimental social science and apply it to a real-world setting. And I really sort of realized this a few years ago when a reviewer asked us, a reviewer who actually sort of liked the paper, and he just requested that at the end we could sort of speculate about what we'd learned that could apply to real-world organizations. And when I thought about it, I realized that I didn't really feel confident saying anything could be learned that would apply to real-world organizations, because there were just too many things that we had excluded from our simulation or from our experiment that might turn out to be really important. So we thought about, how could we close this gap between the desirable features of lab experiments, which are really that you have a lot of experimental control and that you have a high degree of instrumentation. You can really observe what people are doing, and you can manipulate their environment in ways that allow you to test your hypotheses. But at the same time, we want to have something that is realistic enough, something that is complex enough that it has good external validity. So we were casting around for what we might sort of think of as the model problem. So in biology, we have model organisms, we have C. elegans, we have Drosophila. These are very, very simple animals that we can study in great detail because they're simple, but they're also complex enough that what we learn from them may be useful for other kinds of more interesting questions in biology. Can we find a similar sort of model problem in social science? And so about that time I met this guy, Patrick Meyer, who had started an organization called the Standby Task Force. And in 2010, the Standby Task Force was formed during the Haiti earthquake. And what Patrick realized is that there was a problem that needed to be solved. The problem is that when a disaster like this happens, the UN Office for the Coordination of Humanitarian Affairs, UN OCHA, comes in to oversee the crisis recovery process. But UN OCHA has a problem, which is that they have about 24 hours to decide how to allocate resources, and there's too many things happening on the ground for them to figure out where the most needs are and how to get the resources there. So there's an information gap that they suffer from. Patrick also realized that increasingly there was a tremendous amount of information being generated off of the ground, but it was not of a form that was accessible or interpretable by UN OCHA. So it's sort of basically social media data. People are posting things on Twitter or on other kinds of websites, or they're sending text messages, and they're noisy and they're unstructured, but they nevertheless contain a lot of useful information, on the ground reports of things that are happening, and often accompanied by images and videos as well. And so the role of the Standby Task Force was to act as an information intermediary and take all this noisy, unstructured data and turn it into something that could be interpreted by the UN, namely a map. And so this is what they produced. It's called a crisis map, and it is a map of the crisis. And it contains sort of annotated information about things that are happening on the ground that are of use to first responders and outside agents. So crisis mapping has since become a thing over the last few years. They have conferences that are larger than this one. They have lots of different organizations. And as you can see, they sort of have a hodgepodge of websites and tools that they use and platforms that they use to try to coordinate. They chat via Skype, they use Google Docs to write instructions down and schedule people to monitor social media during crises. They use OpenStreetMaps to build their maps. So they have a kind of a mishmash of tools and platforms, and they have deployed in a variety of crises over the last few years, in Libya in 2011, in the Philippines in 2012 and 2013. And yet, their problem is that they don't really have a sort of systematic way of studying what they're doing or of learning about how to do it better. And so there was a sort of nice coincidence of interests between us as social scientists seeking to understand how groups of people solve problems and this very real-world problem that is trying to understand, or a community that's trying to understand how to solve this problem. And so what we built and this is with Andrew Mao, who just got his PhD from Harvard and will be joining us as a postdoc later this summer, and Winter Mason and Sid Suri, my colleagues at Facebook and Microsoft Research. So this is crisis mapping in a lab. And what you're watching here is an actual speeded up experiment, 1 hour experiment, in which a group of 32 crisis mappers who were recruited from Amazon's Mechanical Turk in August last year were given 1,600 tweets that are real tweets that were produced during Typhoon Pablo, which hit the Philippines in December 2012. So this was an actual deployment of the Standby Task Force. Patrick generously gave us the tweets that they themselves had used to produce their own crisis map. And so we are streaming these tweets in on the left-hand side here. And you have these 32 individuals who have had a little bit of training on how to use this platform, but otherwise no experience or knowledge of crisis mapping. And we didn't tell them what to do or how to organize. We told them that they needed to map certain types of events. We didn't tell them how to interact with each other. We wanted them to figure that out on their own. So you can see that they are taking these tweets and they're deleting some of them, and then they're putting others into this little spreadsheet in the middle, and then they're classifying these events in terms of what type of event it is. They're giving a verbal description of it. They are then just trying to figure out where it's happening, and they have to find the correct region and the correct province and the correct city, and then they even have to give a latitude and longitude. And then this event manifests itself on the map on the right-hand side. And while they're doing all of this, they're talking to each other and they're interacting and they're trying to figure out, what are we doing? How should we be doing this? Who's doing what? You just made a mistake. Can you go fix it? So they're talking about all sorts of things to do with trying to solve this task. So one question you might ask is, can they actually do it? And we weren't sure that they would be able to do it because we had tried to do it ourselves, and we had given it to some of our colleagues in the lab to play around with early versions of this platform. And it's actually really difficult. The data is extremely noisy and ambiguous, and you have to sort of go and do searches, open another window on your browser and try and search for things, and half the tweets are in Portuguese. So, I mean, it's really a mess. Nevertheless, this is the comparison. On the left-hand side, you see somewhere between 18 and 32 volunteers from the Standby Task Force who worked for a period of 12 hours in December 2012, and that's the map that they built. And then on the right-hand side, you can see what 16 Turkers did in an hour in August 2014. And actually, these maps are remarkably similar, and the performance, as I'll show you, is remarkably similar. So there's sort of this is an experiment, but it's one that is very close to the actual real-world task, right? So there's a lot of external validity here. Nevertheless, it is an experiment, and so this is the experimenter's point of view, or the interface that the experimenter has. So you can see that we are actually not running just one group of mappers, but many groups simultaneously, and many groups of different sizes. So some of these people were doing this task on their own. Others were doing it in groups of 2, or in groups of 4, or in groups of 8, or in groups of 16, or in groups of 32. And they're arriving into this virtual lab environment, and we're putting them in a lobby until we get enough people in the waiting room. And then we let them out of the waiting room, we randomly assign them to these groups of different sizes. So we ran a bunch of different sessions, and the most that we ever had at any one time was about 100 people, which is not as many as we would like, but it's still a lot. The other point to note is that that this environment is highly instrumented. So, Andrew wrote about 30,000 lines of code to make this run. It's all available on GitHub, by the way, so for those of you who are wondering if you can get access to it, this is something that we would like other people to use as well. But all of this data is being logged. So you can see this is 16, I think this is a group of 16. So each one of these lines corresponds to a single individual in a group, and every one of those little colored squares represents an action that is, the x-axis here is time, so there's 1 hour of time there. So this is every single thing that everybody did over the course of an hour, color-coded by the type of thing that it was. So if you're filtering out one of those tweets, it's colored red. If you're classifying if you're filling in those fields in the spreadsheet, it's colored green. This is the high-level classification. If you're checking somebody else's work, it's orange, and if you're talking to people, it's pink. And so you can sort of see how, and I'll show you how that data can be reduced later on. So we're actually sort of measuring everything that everyone is doing and also everything that everyone is saying to everyone the whole time. And if you're worried about this seeming a little big brothery, this is something that we're very clear about when we recruit people to participate in this experiment. So what do we do with all this data? Well, we want to understand how the narrow question we're asking here is, how does the group size affect performance? So what is the optimal size of a group for solving this particular problem? And so we have to have a nice performance measure, and the performance measure, the way we do that is we first construct what we call a gold standard map, which is we take all of the maps produced by the groups of different sizes. We combine them all together so we have the union of all of these events that they report, and then we dedupe all of these event reports and we hand check them for validity. So we have a map consisting of about 50 different events, and we know exactly where they are and what sort of events they are, and so we can then go back to each individual crisis map and we can score them for their performance, and we have just sort of 3 very standard measures. First, we have precision, which is just what's the probability that an event that you report shows up in the gold standard. The second is recall. Of all the events that show up in the gold standard, how many do you report? And finally, the F1 score is just the harmonic mean of precision and recall. And we concentrate on F1 because it penalizes both false positives and also false negatives, and they're both important for this particular task. So but I'll show you all 3. Okay, and finally we can compute this at any point during the experiment. So you can sort of stop time at any point during the experiment. You can say, well, what would have been the gold standard map that would have been produced at this point in time? And now we can score everybody relative to that gold standard map. And so why would we do this? Well, we want to see, first let's just sort of check that sensible things are happening in this experiment. And so this just shows how all the groups of different sizes, their average performance is changing over the course of the experiment. And so this is an encouraging plot because you can see that the larger groups are in fact outperforming the smaller groups. So the more people you have doing this task, the more stuff they're getting done. And also, each of these groups, regardless of size, is monotonically, or at least on average, is monotonically improving its performance over time. So the groups are sort of properly incentivized. They're actively working. They're trying hard to get as many events as they can and to make sure that the events that they do get are correct. And we got a lot of corroboration of this from the exit surveys that we asked people to fill out afterwards. They took this task very seriously. They also were sort of well motivated because the compensation that we offered them ranged between about $6 for the hour and $15 for the hour. So they were all guaranteed of a reasonable income, but they could get a lot more by working hard and performing well. Finally, aside from this sort of the largest groups at the very end, you can see that the improvement in performance is roughly well, it's not exactly linear, but they're not running out of work to do. So that's really the important point that we want to get here, that we don't want performance to be an artifact of some groups simply running out of work. Right? So we want to make sure that the job is big enough that, that everybody has work to do all the way up until the end of the experiment, and that's certainly true up until about 75% of the way through the experiment, but it doesn't change our qualitative results. So from now on, we're really going to focus on the performance at the end. So the rest of the results will be at the end. Okay, so what happens? Well, so this is the first, sort of main result. So this is F1 score, and all the dots refer to all the groups, right? So this is really just all the data. So there's about 300 people in this experiment, but a much smaller number of groups. And you can see, and the green line is just the best fit curve. So you can see that there is performance is increasing with size, which is nice. But that it is increasing with strongly diminishing returns. And so that's been driven essentially by recall. So precision really doesn't increase or decrease with group size, but recall does. And so the other comparison to make is with this dashed red line, which is the performance of the standby task force. So you can see that as these groups get around about the same size as the standby task force, they're doing roughly as well, even though they have about 1/12 the amount of time. So there's sort of an interesting comparison with the real world. But you might wonder, well, the big groups are getting more work done, but they're much, much larger than the small groups. So there's clearly a sublinear improvement in, a sublinear improvement in performance. And so in some sense, the individuals are on a per capita basis outperforming the groups. And so you might think, well, really, what this is showing is not that you should get a group of people to do this, but that you should just allocate it to individuals as you would do sort of in a standard crowdsourcing application. But this is a little bit misleading because even if individuals are more productive in some sense, they lack the ability to coordinate. They're not in a group. And so it's potentially, so you could imagine in a worst case scenario that a bunch of individuals are all finding exactly the same events, and so their performance is completely redundant. And so we'd like to check this, we'd like to have a way of comparing the output of groups of different sizes in an apples to apples way. And the way we're going to do this is to create synthetic groups by combining the maps of different individual workers. So we take our 18 individuals who are assigned to the n=1 condition, and by sampling without replacement, we can randomly construct these synthetic groups and then compare their performance to the performance of the actual groups. And so this is what this plot shows. So now the error bars refer to these synthetic groups, and you can see something interesting, that as the group size increases initially, sure enough, their performance is going up. But as they get larger, their performance goes back down again. So the performance of the synthetic groups is non-monotonic. And this has largely been driven by the precision. So what's happening here, it's like the opening of Anna Karenina, where Tolstoy says, all happy families are the same, but all unhappy families are different. Here, all correct events are the same, but there are many, all incorrect events are different. So there's many ways to be wrong, and only one way to be right. And so these individuals are reporting many more incorrect events, and so are being penalized for precision. What the groups are doing is actually, even though they look like they're being less productive, they're spending more time checking each other's work, and more time collaborating, if you like. And so this is what we can see here, is that if we measure effort on the left-hand side, so this is the total amount of work that people are doing in the groups, it is indeed going down with group size. So this is what you would predict from the social loafing literature, that as people have more other people around, they work less hard themselves. But on the right-hand side, you can see that they're doing more work together. So the typical number of people who are working on the same event has increased by more than doubles as the size of the group increases. And so what we think is going on is that this collaboration effect is outweighing the loss that's occurring because of lowered effort. So one of the things that I talked about earlier was specialization and division of labor, and that this is thought to be a very important, I mean, this really is clearly important in the real economy, that every firm you look at has enormous specialization going on. Now we're bringing in undifferentiated workers from the outside and giving them very limited amounts of training. They don't have any specialized abilities in this task when they start, but they are actually doing some specializing. And so we can see that here. This is the last quarter of the experiment. This is all of that data that I showed you before compressed onto a single line. And so in the last last 15 minutes of the experiment, we're now grouping people by their dominant activity. So each one of these circles corresponds to an individual sized by how much total work they've done. And then we're coloring them according to their dominant activity. So these guys are still filtering, these guys are classifying, these guys down here are verifying the work of others, and these guys over here are talking a lot. So this Yahoo individual is not just a chatterbox. He's actually trying to get people to do stuff. He's actively trying to coordinate the work of the group. And so you could sort of think of this as the emergence of a leader. Nevertheless, this specialization doesn't seem to help very much. We do see that, so this is sort of a more quantitative view of how much specialization there is. This is just entropy. So we have a distribution over types of activities, and then we can measure the entropy of that distribution. So low entropy corresponds to everybody working on the same thing, and high entropy corresponds to equal allocation of effort to all things. And so you can see that, that groups are showing an increase in entropy, which is what you'd expect. Interestingly, individuals are not, you would sort of expect that individuals would have decreasing entropy with group size, that each individual would be specializing on one particular thing, and that's not really happening. And furthermore, we don't see much relationship between entropy and performance. So this was puzzling to us at first, but then we realized that the entropy measure is maybe the wrong measure, because it's really just describing how much, it's treating all types of activities as if they are equally valuable, and that may not be the case. And in fact, what we now suspect is going on is that if you look at the allocation of effort to different types of activities, you see something that's a bit clearer, that individuals proportionally are spending much more of their time on classification, whereas the larger groups are spending more of their time on other things like filtering. So there's a huge drop in per individual allocation of effort to classification. So this sort of puts an interesting wrinkle on the social loafing result, which is, it's not that just that people are exerting less effort, but they're actually shifting their effort away from the sort of, some sense, the more difficult element of the task, which is classification, and they're doing the easier things, which is just filtering the tweets on the left-hand side. But this does not contribute as much to the global output. Okay, so just to summarize quickly, what do we find? We found that individuals exerted more effort by themselves, which is consistent with social loafing, but adds a couple of interesting wrinkles to that result. First, we're not looking at a unidimensional task, we're looking at a multi-dimensional task, and so we find that people can move their effort around as well as exerting more or less effort. And secondly, it's not really free riding that we're seeing, or at least we tried very hard to avoid incentivizing free riding, because everyone was paid according to their individual effort. So if you did less work, you got paid less, regardless of what other people were doing. So people in larger groups didn't really have an economic incentive to free ride. So we suspect that something else is going on here. The other thing that's interesting is that in spite of all of this, the groups benefit in a different way, which is basically that their ability to coordinate with each other had such an improvement on their precision that they were able to outperform the synthetic groups. And in fact, to an extent where they could even match the performance of the real world deployment in this exact task. And finally, I just will note that we're very sort of interested in why the division of labor didn't help more. Was it because we didn't give them enough time? Was it because we didn't give them enough training? Is it because the task itself is still not really suited? It doesn't really reward division of labor. So there's lots of interesting questions that we can pursue with this framework, but I see I've run out of time, so I will stop talking and allow some questions. Thank you. Okay.
Oh, thank you very much, Duncan. I'm sure there will be quite a few questions, so please. Yeah, I'm just going by what I see, so go ahead.
Well.
Fascinating talk. I've been involved in research on the evolution of behaviour in groups and with different kind of incentive structures. And one thing we start is there is a kind of sometimes a self-sacrifice in the group. And it looks, their performance doesn't look too good. They're part of the engine that makes the rest of the things. Do you detect anything in
So we call it the plus minus, which is what they call it in basketball. So, like, you know, and there's a measure of performance in sports, particularly in basketball, where you know, an individual, or the other thing we call it is the Shane Battier effect. So Shane Battier is a basketball player in the US who is sort of famous for not looking particularly good. He doesn't seem to be a great player, and yet whenever he's on the court, his team does better, right? And so they've sort of figured out that what he does really well is he marks the opposing team's best player, right? And so he's good at sort of neutralizing the best player on the other team, but this doesn't really show up in standard performance metrics, and so you have to look at this plus minus. That's something that we haven't really looked at yet, to answer your question, but it's definitely on our list of things to do. So I think it's a really interesting direction. Thank you. There's one at the back there.
Yes, there's a question.
Hello, thank you for the presentation. What type of approach did you do to measure self-organization, if there was any criticality or emergent behaviors? It's a really interesting topic.
So we are, this is still in progress, but we are, we have a couple of different network structures that we're interested in. So one is we can construct a collaboration graph by looking, you know, it's essentially a bipartite network of events and people, and if you worked on the same event as someone else, we can draw an edge between you, and that could be a weighted edge. And there's also a communication graph where if you're talking to someone, or if you talk and someone else responds, we can infer that there's a directed edge between those two individuals. And so you might think that the properties of those networks would have something to say about the performance of a group. And we've sort of done some preliminary work. We haven't found anything that is particularly striking at the moment, but that's something that we're going to push on further. So we absolutely want to understand, you know, the properties or the features of self-organization, particularly in these larger groups, and whether some groups organize in a good way and other groups organize in a bad way. So that's definitely on the list of questions. Thank you.
Okay, one short question.
So you started out saying that you do these virtual labs set up because you want to generate knowledge that is generalizable, say, beyond, say, a classic lab research. So which findings would you highlight that you say are robust enough that they would generalize, say, or contribute to theory that is generic enough?
Well, so what we would really like to do is try to close the gap a little bit further, which is, well, so first of all, we might do another round of experiments where we try to give people instructions on how to organize. And also we want to do some optimization of types of people to groups, so that rather than randomly assigning people, we first we sort of do a pre-test where we put people through an experiment like this, and then we observe that certain types of people are good at certain types of things, and then we attempt to sort of optimally combine them into groups that we think will have the best collective performance. So that will require another round of lab experiments. either in parallel with that or after that, we hope to then deploy in the field with the standby task force. So they actually want to use this platform themselves, and so that would be great. They can take the platform and they can go and recruit a bunch of people the way they normally do, and they can do their deployment, and then we can deploy sort of in an A/B test style way in parallel with them, recruiting people off Turk and organizing them however we wish to organize them. And then we can really have a sort of a proper, valid comparison measure. So I don't think that there's any. I would be cautious about taking any result here and telling the standby task force what to go do. But I think within sort of 1 or 2 iterations, we will actually have really actionable research that they can use. So that's the plan. Okay. Thanks for asking.
Well, we are looking forward to that. Thank you very much again. And, well, there's a present for you. I don't know what's in there. Okay, so our next speaker will be Matthew Jackson. And actually, like with Duncan Watts, probably hardly any introduction is needed. Matthew Jackson is the William D. Eberly Professor of Economics at Stanford University. He's also external faculty member of the Santa Fe Institute. He has gained impressive lineup of awards for his very important work in bringing together economics and networks. I'm not sure whether he brought economics into networks or networks into economics, but he brought them together in a very, very important way that inspired many people in their follow-up work, and his own work is, really central in this field. So we are very much looking forward to your presentation. Matthew, I leave the title to you.
Okay, thank you.
And I said the time was started.
Oh.
Could you open it again?
Open what again?
Yeah, like and then restart the presentation. I think it looks.
I think it's just the screen it needs to switch to
but with
number
this,
2.
Okay, some technical.
So this is cable number 1. It's number 1.
Okay, let me try this.
Was working before. Another. Okay, there it is.
Okay, let's start. Okay. You got it? Great. So thank you very much, first of all, to the organizers, Santo and Michael and Karen, who's, I haven't seen her, but thank you, and also to Otto University. It's a great pleasure and quite an exciting program. So I'm going to talk about a long-term project that I've been working on with Abhijit Banerjee, Arun Chandrasekhar, and Esther Duflo. And the main issues that we're looking at here have to do with trying to understand how networks affect information transmission. And in particular, 2 things I want to focus on today are how it affects what people know about the networks that they're embedded in. So not only people's information that they're getting from other people about things that they should be doing, but also how they obtain knowledge about the network. And secondly, what's known as multiplexing, which has to do with how different types of interactions influence each other. So trying to understand to what extent the advice networks and opinion formation that we go through depends on other kinds of behaviors that we're invested in. And in particular, one of the things I'm going to spend a little time on in terms of the basic structure here is trying to understand, first of all, how to measure centrality. So I'll review some work that we've done earlier, at the early part of this project, which then will tell us how people come to understand who's influential in the world around them. And this is really a computational problem that people are going through. So there's actually interesting work by David Krackhart, which suggests that people aren't very aware of the networks around them. So if you actually ask them to name people who are sort of second-order neighbors or third-order neighbors, or ask them about relationships about people who aren't directly connected to them, they're not very good at telling you who's connected to whom. And here we're trying to figure out whether they're aware of who's influential in the network. And they're going to do very well at that. And so we're trying to understand why they might be good at naming who's influential in the network, but pretty lousy at naming who's friends with whom and what their network looks like around them. So we'll tell a story about that and actually show you some data. And the latter part of the talk then will be about multiplexing, which has to do with the fact that the networks that they're using to obtain this kind of information can be affected by the different kinds of behaviors they're involved with. And what we're going to look at is how access to certain kinds of credit and formal loans is actually going to destroy some of the social links that they used originally to gather information. And so we'll see a change in network structure in response to access to markets, and we'll try and understand why that's going on and what we can say about that. Okay, so in terms of outline, here we're going to start with just talking about some background on measuring centrality in these networks. Then we're going to try and see how good people are at naming influential individuals, and then tell a story about why they might be able to do that well. And then finally, I'll come back to the multiplexing start. So let's start with just some background about centrality. And I'm going to tell you, Jen, I'll start with a background on an empirical project. So this is work we've been doing for about a decade in rural Karnataka. And in particular, what we were doing is looking at the diffusion of microfinance in a series of villages in southern India. And a bank was going in, and the reason that they were interested in partnering with us was that they were having very different levels of participation in different villages that looked pretty much identical to them. So they would go into one village, they would go into another village, which was pretty much indistinguishable, and they would get high participation in one and low participation in another. And it really wasn't worth their while if they weren't getting participation at a certain rate, roughly about a 20% participation rate in a village. It wasn't worth their while. And so in our data, it ranges from about 7% in some villages to about 44% in others. So there's a wide range, and we're trying to figure out why. And so the first part of this is just going to be that word of mouth was really important in getting information out, and if they were hitting central people in these villages, they were getting more information take up. And then we'll use this to try and understand how people are aware of other individuals around them. So these are 75 villages in rural Karnataka. The bank entered 43 of these villages and did not enter 32 other villages. That's actually going to be very useful for us in the second part of the talk, because then we're going to be able to see how do these villages change in reaction to having microcredit. So 43 of the villages get it, 32 villages don't get it, and we actually mapped out all the networks before, we mapped out the networks after, and we'll be able to compare them. And so we'll be able to say something about what systematic changes occurred in these villages in response to exposure to formal credit markets. Okay, so here we are in Karnataka. Most of the villages are within a reasonable distance of Bangalore, within 100 kilometers of Bangalore. The villages are about 1,000 people each. Part of the reason that they're nice from a social science perspective is that these villages are fairly self-contained. So the people tend not to have many interactions outside of the villages. Most of the villages interact entirely within. They're fairly poor villages, about $1 per capita income in a village. And so word of mouth is going to be the main conduit of information, and we'll track that. So here's a picture of one of the villages. They tend to be fairly agricultural, finger millet, some depends on the area, some rice production in a couple of the villages, sericulture, silkworms, and so forth. And so what we did is we went in, we surveyed the villages beforehand, and now we have about 92 to 97%, depending on the village, of adults surveyed. And so each one of the clusters there is a household. Those are the adults in the households, and we asked them a series of different questions. So we have 13 different types of networks. And the kinds of things that we asked, for instance, would be, if you had to borrow 50 rupees for a day, who do you go to? And so they could name another family. We had questions of who do you go to temple with, who do you go to for advice, who comes to you to borrow kerosene or rice, who do you go to in emergency for medical help, who comes to your house to visit. So we have a series of different questions. And then on top of that, we have a lot of demographic information. So wealth variables, education variables, profession, caste, and so on. So what we're going to do is in terms of what the microfinance organization did was it would go into one of these villages and tell a series of people that they thought were good leaders of the village. So they went in, they found self-help group leaders, shopkeepers, and teachers, and tried to tell them, look, we're going to offer microfinance, spread the word, spread the news. So these were the initial injection points into the networks, and they were trying to spread information. The question is, how well did they do in terms of spreading information? And so what we know is who the people that they first talked to are, and then we have participation over time. So we can sort of track how this diffuses over time, having seen the initial injection points into the villages. And in particular, then we can see, do the initial injection points matter? Does it matter who they talk to in the different villages, and how should we measure that? And so let me just start with some obvious hypotheses. So the most basic centrality measure we have is degree centrality. You just want to talk to the most connected people. So, find people who have the most connections on the left network 7, right network 6, tell them, and they're going to be the best people at spreading information. Obviously, to this crowd, I probably don't have to tell too much of this, but just to make sure we're all on the same page, degree centrality is not a great measure for this kind of process because it really only picks up very local information. And it could be that people that have the same degree have different numbers of connections in terms of how well they reach out to others. And so here we have two twos. One's connected to a 7 and a 6. The other's connected to a 2 and a 2. And you can see further differences from these. And so the measure that we usually use to sort of deal with this is eigenvector centrality. And so the idea behind eigenvector centrality is instead of just counting how many neighbors you have, you also keep track of how well connected those neighbors are. So you want your centrality to be proportional to the sum of your neighbors' centrality. Now that becomes a self-referential system because their centrality is proportional to their friend's centrality and so forth. But this is just a simple eigenvector calculation. And luckily for us, in terms of the mathematics, the Perron-Frobenius theorem tells us that these things are well defined. There's a unique eigenvector that's going to have all non-negative entries. So we have a nice measure here, and that'll give us a better feeling for whether somebody's really well connected in terms of maybe spreading things beyond just the first order, but multiple orders. So the idea of that is, here if we go back to that network, now the 2 in the middle has a much higher score than the one at the edge because it's well connected in terms of its friends are well connected. Okay, so that's two measures, but these are pretty much off the shelf, and they're not really designed to pick up a diffusion process. So if we want to think about a diffusion process, why don't we just directly model that and define centrality based and influence based on the process rather than something off the shelf? So we can work with what we call diffusion centrality, which is the following concept. We just start at some node and then just follow a really simple epidemiological process, the simplest sort of process that we know for contagion. Each person randomly bumps into their neighbors with some probability, in this case P. We run this over some time and information spreads out through the network. Okay, so we can keep track. And if you do just a simple, simulation here, we start with some node. If we set P to 0.5 and T equals 4, then there's a half a chance they bump into either neighbor at any point in time. So, they happen to tell one of their neighbors. Second period, everybody who's active can now interact with other people. And this is just going to randomly spread. If we did that for 4 periods, this node would have a measure of 13 in this particular simulation. Okay, so you could do that for another node. This node's a little worse placed. They end up with a score of 6 in the simulation. So you can look at this measure for different probabilities of interacting with people in different time periods, and that'll give you a measure of how central a person is in the network. Okay, so one thing you can show, which the first part's very obvious, the second part takes a little work, but is fairly straightforward. If you define this measure not just in terms of the simulation, but in terms of the expected number of times that information is going to be heard by different people in the system, starting from some node, then what you're going to end up with is that if communication occurs just once, this is just proportional to degree, right? So I just reach how many people I can talk to. If it occurs many times, then eventually this is going to converge to eigenvector centrality. So this kind of process, you could think of eigenvector centrality as one extreme where we talked forever, and degree centrality is a really short communication process, and the diffusion process is going to be somewhere usually in between. It's going to interpolate. So we can look at the data and then see, how well we know who the bank informed. We can see whether that explains, these initial injection points explain the eventual participation rates in the different villages. Okay? So here are the 43 villages. And then the first graph here is just what's the degree of the people that they talked to. So what's the average degree of the first people that they contacted in the village, and then what's the eventual participation rate? So for instance, the villages down here, it's about, these are the 7% villages. The ones up here is 44%. And then you see there's no relationship between the degree of the people that they first talked to and the eventual take-up. When you look at eigenvector centrality, you begin to see a positive relationship. It's significant. Having higher eigenvector centrality was a good predictor. If you do diffusion centrality, it's a little hard to see from this picture. It does better than either of the previous ones. And if you look at running different centrality measures, if you run a horse race between these and look at a regression, basically you see diffusion centrality is highly significant in terms of predicting the microfinance participation. If you look at other standard centrality measures, they don't do as well. And in particular, you begin to see that you're picking up a much higher R squared in terms of how much of the data you're explaining. So you explain almost half the data when you include the diffusion centrality. You get about a third of the data off of the other measures. It's not surprising that it's doing better given that it nests the other measures. But it tells us that modeling this process explicitly can give us then some toehold on exactly what was going on and why they were doing better in some villages than other. Okay, so that's sort of the background and where we started with this project. And then the question comes up, we have information that says, okay, look, if they want to figure out who to first contact in villages to be more successful, they ought to contact people that have higher, say, diffusion centrality or eigenvector centrality. That requires network knowledge. So that can be expensive. If they actually go in and surveyed every household in the village, they would be better off just telling the households about the product rather than going through and mapping out a census the way we did. So this is information they're often not going to have access to. And the question is, how could you get information about who's influential without actually mapping out the network? And so what we thought was, why don't we just go and ask the villagers? So we'll just ask them, who are the right people to talk to? And obviously we can't ask who's eigenvector central in your village. But we could go in and ask them, who's a good person to talk to sort of spread information in the village. And so that's what we did. So we went in, we asked every adult, who is the best person for starting diffusion? We're going to work with households as the units, and we did this in 33 of the 43 villages for various financial reasons. So the questions we asked them are, if we want to spread information about a financial product, who do we talk to? To make sure that it wasn't biased, when you asked about financial products, we also asked if we want to spread information about a music event, drama, or fair, we would like to organize, who should we talk to? It turns out that the results are pretty much the same across the two, so I'm just going to tell you, about the first question. So first of all, they do fairly well at telling us who's central. And in particular, when you look at the number of people that actually get named in a village, it's very concentrated. So only 5% of the villagers actually get named by somebody when we ask this question. So they're often naming the same one. Conditional on being named, people are named about 9 times is the median. So they're concentrating. And then we can ask, so they're naming the same people. Are they naming highly central people? And what this graph does is look at what's the probability you're in the top 10% of centrality, in this case of diffusion centrality. So if we look at this, first of all, these are the people who are not nominated. What's the red bar? This is so not nominated and not a leader. So this is 90% of the population falls into this bin. That's what the red is. And they have only about a 10% chance of being in the top 10% of centrality. So you're pretty much just getting a random draw in those cases. What if you weren't nominated, but you had the leadership status that the bank was using? So if we just went in and followed the bank's way of identifying people, were they identifying highly central people? They're doing better than at random, but they're still not doing that well. What if you were nominated, but not a leader? So if you're nominated and not a leader, now you have about a 20% chance. And then when you're nominated and a leader, you get up above 40%. So combining this information of people telling us who's central and then also looking at their leadership status gives us a fairly good prediction comparatively of whether or not somebody's going to be highly central in the village. Okay. So one question then is, how do people actually come to know this? Because generally they're naming people outside of their immediate friends. So they're naming people in the village that are further away. And this is the idea of gossip. So we usually think of this gossip as having sort of a negative connotation. Here it has a positive connotation. So the idea is that imagine people just sitting there, and over time you hear news about people. You hear news about other people. And what we're going to do is just model the process of people spreading gossip in a village the same way that they would spread news about the microfinance. It's just going to randomly bump from person to person. So I bump into somebody and I tell them whatever I've heard with some probability in any given period. So this gossip process just spreads out through the network. And we can keep track then of the number of times that person J has heard news about each other person. So we get this, this kind of information popping out. Arun's moved to Stanford, Matt has a new MOOC, Esther won an award, and so forth. So this kind of information spreading out through the network, people are tracking it, and then over time, each person is going to do a really simple calculation. So they're not trying to keep track of their network, nothing around them. All they're going to do is count how many times I heard about each person. So I've heard 5 pieces of news about Arun, 7 about Esther, 4 about Matt, and so forth. So I have this mental bin, and I just going to track people, how often I hear about people. And the idea here is what we've done is just reverse this diffusion process. Now we're looking at it from the receiver's perspective rather than the sender's perspective. And the question is, if I'm just a receiver and I sit there and listen, am I eventually going to have the same ranking that we would like in terms of how good people are at diffusing? Okay. Okay. So the idea, what you can show here is every individual in one of these societies, ranking of other individuals under network gossip will be according to the ranking of diffusion centrality for large enough P. So what you can show is that a listener who's receiving that information is eventually going to be able to rank the other nodes accurately in terms of diffusion centrality. So if I'm in the village and I'm there for long enough, just by following this simple rule of thumb, I can end up doing a fairly complicated calculation in terms of ranking other individual centralities. Okay, so what we did then was a controlled experiment. So are the people that they're actually naming for us good at diffusing information? So we had our own controlled experiment. Instead of diffusing microfinance, what we did is we allowed them to play a game where we gave out cell phones. We partnered with a cell phone company that wanted to give out cell phones in these villages. And so we told some people in villages, and we said, look, spread information. Anybody who comes has a chance to win a cell phone. So they could roll some dice. Depending on how the dice came up, they won either rupees or a cell phone. And so it was fairly attractive for people to have this information, to spread it, and to participate. And there was no rivalry, so people could come up and get as many people could get phones as there were in the villages. So what we did is we did 3 different treatments. 70 villages, so these are different villages. We did a random seeding. We just picked out randomly people. 70 villages, we went through and basically identified village elders, village leaders, the same way the bank had done. And in 70, we actually asked people for nominations, and we picked those people to see if they were better at spreading than just looking at leadership status or random individuals. And so here's the what the outcomes are for the random non-gossip villages. So here, depending on how many people actually, so these are the number of seeds that we had, and sometimes some of the seeds, so we picked the seeds, we weren't always able to reach all of the seeds. So they're between 1 and 5 were the number of seeds, and these are the number of calls received in these villages tended to be between 0 and 20. So fairly low feedback from the random villages. If we use the elders, you do a little better. Sometimes you get above 20, sometimes you get into the 30s, but you're still getting largely down in this lower region. If you use the people that they're telling us, the gossips, then we start getting higher levels. So now we get into the consistently in the 20s and 30s, and I think the highest was over 100. So news is spreading much more effectively when we're using the people that individuals are telling us to use, rather than just looking at some sort of other leadership status in the villages. These are just the CDFs, and obviously they're statistically distinguished from each other at a pretty high level. So you're getting many more calls received from asking for the nominations, rather than just going in and doing it by random or using leadership status. Okay, so that takes us through. At this point, we've seen, the diffusion depends on whether you hit important people. People seem to be good at naming who's central in the villages. One story for that is that the information networks allow them to process that information. And so the last part we wanted to go through is to see now whether or not microfinance actually affects the networks that people use for information and affects their other kinds of interactions. So some of these villages were exposed to microfinance, some weren't. Is that changing the way that these networks are constructed? Okay, so now what I'm going to do is I'm going to take you through just a quick economic story of favor exchange. And what we'll do is say, why would it be possible that the fact that now I have loans is going to change my social network? And the idea is that, okay, I used to borrow and lend money with different individuals because I had needs basically for income smoothing. And now I no longer have that need because I can borrow from the bank. The question is whether that has external effects. Does that mean I also don't now borrow and lend kerosene and rice? Maybe I don't also ask that person for advice anymore. So the disappearance of some types of relationships might have affect the other relationships that are present. And so we can think of, basically, before there's some cost of giving a favor, for instance, loaning some money to a neighbor, and I'm only going to be willing to loan that money to a neighbor if the current cost of doing that is less than the future value of the relationship. So if you think about somebody in isolation, if I'm borrowing or lending money or kerosene and rice or providing some sort of favor, in an economically motivated way, I'm going to be willing to do that if only if the future reciprocity that I get out of this relationship is better than the current cost of actually doing these kinds of favors. Okay, so if we have lots of frequency of borrowing and needing money, that's no problem. We can do that in isolation and it's not going to have any effect. But it's quite possible that these things are fairly expensive. That I don't necessarily want to give a large loan to my friend at certain times. And one way that networks help support things. This is out of work with two students at Stanford, Thomas Rodriguez-Baraker and Shu Tan. Is now the social structure, and this goes back to ideas from Coleman and others. The social structure can put increased pressure on a given individual to perform. So if I don't lend the money when somebody comes to ask me, now I'm thought of as a bad individual, and I can lose multiple friendships, not just one. So in this case, if we put 3 people in a triad, now if one doesn't do a favor for 2, they could lose friendships from both 2 and 3. And so that increased pressure means that we can get more favor exchange. We can sustain more kinds of activities, more things can go on if we have the social pressure instead of just things in isolation. Okay, well, the same principle works if instead of doing this with multiple people, we just do it with multiple types of behavior. So another idea would be, why is there multiplexing important? It's because the fact that we're borrowing and lending money makes it easier to borrow and lend kerosene and rice. I can lend you money today knowing that you're going to lend me kerosene tomorrow, or give me advice tomorrow, and so forth. So we can layer these relationships on top of each other, and they're going to reinforce each other. Okay? So based on this, we can think of relationships where the blue relationship here is supported by the red one, multiplexed with or supported. So we can think of them as being reinforced in different ways. So one by network structure and another by just adding on multiple behaviors on top of each other. Okay. So first of all, just in terms of looking in these villages, when we look at something like borrowing and lending kerosene and rice, which is a fairly expensive activity for these people and very valuable, we see that the fraction of those links that are supported is about 73%, the fraction that's multiplexed, 77%, the fraction that's at least supported or multiplexed, about 92%. So when they're doing these activities, they are doing them in combinations. They tend to be heavily reinforced. And this is statistically very different from a typical node. So if you look at just a pair of villagers, the chance that they will be doing multiple things together would be fairly low. So it's actually when you look at a link being present, that it's being heavily multiplexed and supported, not just any two individuals at random. Okay, so hypotheses now. The idea now that the bank comes in, starts offering loans, one hypothesis is that's going to reduce the amount of other activities because anything that was multiplexed or supported with the money links are no longer going to have that as a reinforcer. That's going to lead to destruction of other kinds of links in the village. Okay? So some links that are supported or multiplexed by such relationships would disappear too, but links that are not supported or multiplexed with money links should be less affected. So when we're going to pull out the money links, we know where they were in the networks. They should cascade with other links around them. But situations where there wasn't any money being involved, we shouldn't see changes in those. Okay. So the timeline again, 2006 we had surveyed the 75 villages. 2007 and 10 they entered 43 villages, offered loans, not the other 32. 2011 and 12, we resurveyed all the villages. So what we're going to do then is compare what's the change in network structure in the villages that were entered to the change in network structure to the ones that weren't, and see whether there's a significant difference between the villages that were entered from the ones that weren't. Okay? And the idea here is that ones that involved money somehow in these combinations should be affected. Ones that didn't have any money but were involving other kinds of relationships shouldn't be affected. Okay, so first of all, what do you see in terms of money? This is the microfinance villages compared to the non-microfinance villages. There's a drop of about 5% in the money links that are supported with money, ones that are supported without, and then just loan links drop at the highest rate. These are dropping, so 5% drop compared to about a 30% base. So it's about 1 in 6 change. Now when we look at other types of relationships, so this is the kerosene and rice borrowing network. What happens to links that were supported or multiplexed with money? Again, we see about a 5% drop. So we see almost the same order of magnitude drop in these links when they're involved with money links, but we don't see that if they were supported without money or they were loan links. There's many fewer of these second categories, which is why the error bars are so large. But basically, they're being less affected. And so we're seeing a more dramatic decrease in these links in the microfinance villages than the non-microfinance villages. And the same thing is true for advice. So you see that the advice network, you see a drop. You actually see an increase, a slight increase, but insignificant in the other case. Okay. So summary on these changes. These relationships can serve as complements. Multiplexing and support are high in the data. We see a significant difference in survival rates of links that were supported and multiplexed with money between these microfinance and non-microfinance villages. So money links are falling, and then links supported or multiplexed with money fall as well. And then when you go through, you can look at other aspects of the networks, and the actual distance in these networks is increasing as well. Okay, so implications, I guess. Here, the exposure to these formal institutions is changing the social structure, and that's something we should be aware of for policy implications. So if we really want to understand the implications of going in and offering microfinance, we should realize that that's going to have effects beyond just the monetary impact on the particular villagers. And understanding this is something that we have to take care of if we really want to design policy optimally. So the fact that it will change the network structure is something that we should better understand. Broader messages here, obviously the network models help us in understanding what's going on in terms of the diffusion of information. They also help us in understanding how people understand the networks around them. And I think it's going to be important to have better grasps of how different types of networks interact with each other, because a lot of the information that we get is completely dependent on other kinds of relationships. So a lot of the information we get is from going to conferences, co-authors, so forth. It's not for explicit information networks. And so understanding these kinds of things ultimately could be very important. So thank you very much for your attention.
Thank you very much for this great presentation. So I'm sure many questions, comments are triggered. Duncan?
Matt, so that's an amazing study, 10 years of work there. Do you have any evidence of, just for the last point you made about the sort of disintermediation of individuals because of the intervention of or the intermediation rather of the bank, sort of in some sense depressing or destroying other kinds of links in the village. Do you have any evidence of any sort of negative social outcome that resulted from this sort of sparsification of the networks?
Yeah, so one thing we don't know exactly in terms of what the long-term impact on people's wealth and so forth is. I think the main concern, so it's very difficult because it's changing a lot of things as well. Now they have more access to credit, and that can lead to investments, and so there could be other things going on in the villages. But I think probably the thing that's most worrisome is that it tends to be very unequal what the consequences are. So the microfinance households actually end up rewiring their networks more, and it's more the non-microfinance households. So the households which tend to be poor and less educated and didn't take out loans are more impacted in terms of loss of relationships. And so that would tend to be more concerning than just the fact that the network's changing is something that we should be concerned about, but we don't know. Maybe it's a positive thing in the end. Maybe they don't need these networks anymore. But the fact that it's happening unequally and it's also happening to people who aren't getting access to the money is more of an issue.
Okay, well, there are plenty of questions. I just go by whatever I see first.
It seems like we may be looking at sort of a low-level transition from a kind of like a mine shaft to Gesellschaft. I mean, just looking at it from very small increments as opposed to seeing like gigantic country changes.
Yes, I mean, this is a very micro look at things, and very much looking at sort of a household level and just asking, you drop some money into one of these households, how does it change their network? And extrapolating from this is a little bit dangerous. So I think this is something that Duncan had mentioned and so forth. When you look at some of these in a very specific context, it's not obvious what more general conclusions we would draw. But I think we do need to understand how relationships interact with each other, and it's something that often when we do network science, we sort of look at one picture at a time, and putting these the multi-layer networks and really understanding how they affect each other is something that hopefully we can take to a larger scale.
Okay, thanks.
Thank you. This is a great talk. So I have a question about the sporties and the multiplex links you talk about. So instead of looking at the effects on different types of behaviors, I was wondering if you have looked at the effects on different types of relationships. For example, in kinship networks, so if you lose, because everybody is linked to everybody else in the links, so if you lose reputation or trust from one of the members, you will lose the trust from all the others. So then you won't get support from any others. But this might be different from in a relationship like a neighborhood. So if you lose the trust from one neighborhood, that might doesn't affect the support you can get from another neighborhood. So.
Yeah, so I guess understanding, this is a fairly basic model of this loss of trust by when somebody doesn't behave, here we just have the immediate people connected in a network impacting that. And it doesn't differentiate between, say, kinship and non-kinship. And when you look into the, some of the economic development literature which studies risk sharing, informal risk sharing, there are differences between sharing with kin and sharing with other people. And one story that would be consistent with this is that, it's hard to sever a kinship tie. It's easier to sever another type of tie. And so there's differences in leverages that people have depending on whether they're related to you or not, and that could make a difference. And so putting this in a larger context could be important as well.
Okay, my question over here. Hi. I'm wondering if the tie decay diffuses in the network. By this I mean, so if one link gets loosened or weakened by the intervention, right, does that affect other ties that the person has to other people that are not directly affected but indirectly affected, so you get this cascading.
Right. Yeah, we see a slight effect, but it's insignificant. So it's not clear whether it's just not a powerful enough test in terms of the resolution that we have, because the number of infected participating households was small enough that it's not clear exactly how far that diffuses. So you get a positive effect, but it's not statistically significant when you start looking too out.
Okay, we have one more question here.
Okay, have you tested here?
Yeah.
Are the centrality measures better than the gossip, intuitive knowledge, let's say, of the village? Have you tested that?
So we have another 70 villages, and we literally just got the data last week. So that's I didn't present that because we didn't have those at the time. But that was the next thing we're doing, and we'll have those data fairly soon. And it's quite possible that the villagers do better than we would do with the centrality. And we're very interested in knowing the answer to that question.
Okay, last question.
Change as well. So this is kind of idea that I got when you were talking about the supported and multiplex latches, but would diffusion centrality also change depending on, for example, the kind of information that you diffuse in a network and also the role of the members in the village? Like, for example, let's say if the village had, for example, like a microfinance manager and a welfare manager, for example, then let's say, I guess like diffusion centrality would also depend on whether you spread like information about microfinance or the information about like music concert or such.
Right. So certainly the networks that we're looking at, the 13 different types of networks, and incidentally you can find these data on my website if you want them, they have very different signatures, and so people's centrality will depend on which networks you're looking at. And it's quite possible that when you're diffusing information that's related to something that's financial, you would use a different network than if you're diffusing information about a fair or a music event. So you actually get much higher resolution than what we reported here by looking at the specific networks. And actually, in these villages, the kerosene and rice network is the best predictor of anything. If you had to just rely on one network, that would be the network you would want to go to. But it certainly makes a difference, and that differs across applications. Yes.
Okay. Thank you very much again.
Thank you very much. Thank you.
Okay, so we move on to the next speaker, who will be Michele Vescovi from Telecom Italia. He is presenting work on creating a living lab on behalf of a whole consortium of research organizations and companies. I won't name them all. You can find them in the program. It's quite a long list. And I think Michele will point that out more. Okay, we're looking forward to your presentation.
So thank you, Andreas, for the presentation. I think I will have a pretty hard task because I have to present 2 years of experience with a long list of partners in a few time, and also coming after these great speakers, so I will try to proceed. If all of us are here in Helsinki today is because technology nowadays gives us a big opportunity. Ubiquitous sensing has gone beyond the only widespread adoption of smartphone. Nowadays, technology enables the collection of personal data of many sources, wearables, sensor in the home, data from services online. And this big collection of highly dynamic data and very various data enable the study of the digital footprint of the people. So enable a critical change in the behavioral analytics and in the observation and monitoring of the human behavior. So nowadays, human behavior analysis can be performed in a completely different way of what is in the past. And in particular, this new scenario has been envisioned already almost 10 years ago when Alex Pentland, calling it reality mining, imagined and performed the first experiment in recording during the real life of people the various aspects of behavior. So imagine to have a big community of people that is monitored and is monitored toward a different set of data, and this community of people can also affected by intervention. And imagine to monitor this community for a long period, then you have this reality mining, and then you have big opportunities for behavioral analysis. And we get inspired by this concept, by this invention, let's say, of Alex Pentland. And in 2012, we created in Trento, in the north of Italy, the Mobile Territorial Lab. Mobile Territorial Lab is a joint open lab made of 4 committed partners, which are industrial and research partners. So we are Telecom Italia, Fondazione Bruno Kessler, MIT Media Lab, and Telefonica. And we create this lab with the support of Trento-RISE, University of Trento, and IDCube. The lab has the objective of explore the partners of behavior, investigating the correlation between the social dynamics and the individual factors with healthy living. So the idea is to understand how to improve the life of the person toward the analysis of their behavior. In particular, we want to explore large data sets that we are collecting, monitoring the people in the real life with a target community. This is done in a different way with respect to the past because we are also working for developing solutions for the users. So giving this mixture of research and industrial, we want to exploit the situation and the experiments we create to develop solutions and to provide the users with awareness and self-empowerment on their behaviors. In particular, we are experiencing in the laboratory these new paradigms for the management of personal data. In particular, we're trying to move to user-centric personal data management. And finally, the final objective is to design personal application and smart city services, starting from a privacy-preserving usage of personal data. Given this objective, the Mobile Territorial Lab has been created involving a community of up to 150 families in the territory of Trento, and with a high community management effort. So the technological support, the experimentation support, and the continuous information toward the community. In particular, as before Duncan mentioned, it's very hard to pass from the lab to the reality, to the real world. And this requires a very complex legal framework and a very innovative technology infrastructure. The Mobile Territorial Lab is a long-term living lab, so our activity are managed in a research campaign. So during the 2.5 years life of Mobile Territorial Lab, we run different research campaigns that we will see later. And we apply into this experimentation co-design techniques to involve the user and engage the user during the life of the laboratory. In particular, with the support of a multidisciplinary teams that goes from sociologists to psychologists, technicians, technology scientists, data scientists, and so on and so forth. The architecture of the lab is based on the smartphone that collects a wide variety of data from the sensors, and that collects this data in the cloud where they are secured and where they are in the availability of the users through the My Data Store. That is a personal data store that allows the user to see all the data that are collected during the long-term experience of the laboratory about themselves. In particular, in these 2.5 years, these architectural settings allowed to create one of the biggest data sets on behavioral analytics that has never been collected. These are the number we have, but we have data of different types, starting from location, air quality recorded through sensor distributed to the users, Bluetooth hits to measure proximity and face-to-face relation, interaction record from calls, text messages, running application to understand the usage of the tools and the smartphone by the user, media events like taking picture, listening to music, record a video, personal expenses, mood. Some of these collected automatically, some of these, like the mood, collected through experience sampling with the users. In particular, all this data, as I previously mentioned, are collected through new user-centric personal data management techniques that we developed as part of the project. In particular, we realized My Data Store, that is this tool that allows the user to control the collection and audit how the data are used by the different applications and by the different analytics. This tool allows also the user to have awareness, so have a kind of personal mirror on their self and on their behavior, and also to compare with the other member of the community and the similar. Starting from all these ingredients and this technological setting, many studies, many research campaigns have been performed into the Mobile Territorial Lab. I will mention some of them with very few highlights of the outcomes. One of the studies has been understanding the social well-being and stress. So we tried to connect and correlate the individual factors like mobility, sociability, with the stress and the mood and the activity level of the users in their real life. In particular, we found very relevant the diversity of the communication patterns and the locations, so how different is, how engaging is the life of the people with their positive affectivity. And we find many correlations between the communication patterns and the stress. So, for example, a high level of weak ties creates stress, while a high frequency, high number of strong ties gives to the person less stress. Probably, as Michael said at the beginning this morning, this kind of setting is very effective to measure what's happened. So probably things that we already know about behavior, but that we can measure and we can demonstrate thanks to this kind of studies. Second study was understanding and predictive spending behavior. So we tried to correlate the routines of the user still in terms of mobility and sociability and their mood to their spending behavior. So we found quite a lot interesting information about that. In particular, we found that diverse social interaction correspond to higher spender, and that it's possible to map the higher and the lower spender with respect to the regularity of the behavior of the users. Then we also studied how the smartphone, how the technology is used by the users and how this affects their wellness. In particular, we also try to understand if the perception that the user have of the impact of the technology in their life, in this case of the smartphone, is consistent. And we discovered that many people does not have a real or fairly correct perception on how is their usage of the smartphone with respect to the real usage of the smartphone. In particular, we also mapped also through the smartphone what we already studied for what concerns the sociability of the people, so that the usage of the smartphone reflects on the affectivity of the person, so on their mood. Finally, we perform also some studies concerning the privacy and the value and the perception of the data and the personal data usage for the users. In particular, a study concerning the monetization of data has been performed in 2013, and this led to very interesting results that have been awarded as Best Paper Award in Ubicom. This was a study mixed by Fondazione Bruno, Kessler and Telefonica, and we discovered that through an auction mechanism, what is the value expected for their personal data by the users. Of course, that would be very interesting to try to see if this, with a second study, if this measure is corresponded by the real behavior. And finally, we studied also the mechanism that can drive the user to disclose their personal data toward other users of the community, in particular trying to apply this study into a social mirror, so a kind of mirror where the user can compare some insights about their behavior with the behavior of the other participants of the community. And we discovered that there are correlations between the lifestyle of the user and how they they prefer to disclose their information. And so, for example, that somehow the better is their behavior, the more they like to disclose it. Better, of course, depends from the kind of index that you apply on the behavior. And we also understood that the curiosity to compare with similar or with others and the engagement given by the quantification of their personal behavior is a driver for the user to let them disclose information to the participants. Okay, after this long experience that lasts since 2.5 years, we managed many challenges, stated before, due to this relation, this tentative to move the behavior analysis outside the lab in the real world, with these real people that participate in the long term, in the real life, collecting data by themselves. And in particular, one of the hard part was to let these people be committed to the participation for the long term, so we are speaking about 2 years, and to ensure the quality of the data collection. We understood that it's crucial to have a high effort on community management, and that is crucial also to provide users some benefits. But we started providing rewards, but we've seen that also rewards have a limited effect when they last for a long time. And so we understood that it's much more important for users to have useful service. So for example, we have seen how providing them tools that enable them to save money, save time, etc., like we did during the experimentation concerning the expenses, has been very appreciated, and the user continued to collecting their data even after the expected time of the experimentation. Usability is also a key point, so we cannot provide monitoring tools to the users if they run out of battery. It seems, of course, obvious, but there are many other usability aspects that must be taken in consideration during this kind of experiments. And in particular, users like to be involved. So they like to be to have feedback, to be involved in co-design, to be involved in the evolution of the laboratory. And we understood that the more was our effort in co-designing the services with them and in providing them feedback, the more were the outcomes and the more were the commitment and the quality of the data collected during the experimentation. Of course, the second very big, probably the biggest challenge, as mentioned also this morning by Michael, is how to make sense of these big and huge data sets. So one of the lessons we learned, of course, we are in a long path. Now we are focusing on the analysis of all the data we collected in the last experimentation. But we understood that it's crucial also that we have a clear idea of which are the features that we want to extract from this data before to set up the experimentation, because we must ensure that the technological infrastructure enable the feature extraction that is necessary for the data analytics. For example, in terms of frequency, in terms of precision of the data that are collected. And also, we must carefully take care of the changes that users have in these long-term experiments. Of course, to run an experiment of 1 month can ensure you to have like a fixed image of the user, but while you are you have a group of participants that participate to different research campaigns in the long term. Also, the participants have they change. So you must prevent their addiction to the research task, and you must consider that they are changing. And finally, the other big challenge that we try to approach in the next future is to scale out of the community. And so I close with the evolution of the Mobile Territorial Lab. We want to strengthen the data fusion that we already have in our technological architecture, but including other data that can provide other information from different aspects of the behavior of the user. For example, we are including data from the car, we are including data automatically from the billing, purchasing, and we are going to include also data from wearables that can give a kind of measure, a scientific measure, not a self-reported measure of some kind of information like the stress and other information about the users. And then, as I already said, increase the community size and his heterogeneity, and so scale out of the specific community. And finally, to extend the Mobile Territorial Lab project in federated models. So creating different territorial labs with specific focus and specific community. So such kind of two parallel the stream of research, one with scaling and one focusing. And in particular, on this direction, we already created a second Mobile Territorial Lab in the city of Livorno, in Tuscany, in collaboration with the National Council of Research, CNR, and the COP, and this second living lab is focused on retail data. So the retail data of the user flow into the data set together with the other tools. So I still 30 seconds to present all the partner of this initiative. That's very, very many. But I want to mention at least Fabrizio Antonelli, Bruno Lepri that is here, so he can also answer to many questions if you are curious about our lab. Chiara Leonardi, Alex Pentland, Nuria Oliver, and Nicola Doppio, and all the others that I cannot mention here, unfortunately. So for the reference, you better have a look at our website, and thank you very much for your attention.
Thank you very much, Michele. I think we should take at least 1 or 2 questions. So please.
Very interesting, but either I missed it at the beginning or whatever. How are you measuring through this platform stress, happiness? I started scanning that paper on happiness, positive and negative affect through a sensoring platform. I'm just
yes, sorry, probably I've been too fast in this part. So the mood actually is measured by experience sampling. So during the experimentation, the user were provided of an application on their smartphone that were asking at periodic time during the day to self-provide their information about their stress, the quality of the sleep, and some other affective information, like they were asked to self-evaluate how positive they feel, how negative. Of course, it was not so simple. It was more detailed, starting from some survey that are from the literature in the psychology area. So they were reporting these data continuously during the whole duration of the experiment.
Okay, we can take one more question and then lunch. Well, I think people prefer lunch. Is that right?
Yeah, I think so too.
Okay, thank you very much again.
Thank you.
Thanks, Andreas. Great to watch.
Well, I didn't manage the time very well, but well, with these impressive speakers.